Hello, in this lecture we will find the size of line segment AE. In the drawing we have square ABCD. We know that line segment DE equals to 8 units, line segment EB equals to 2 units, and we want to find out the size of line segment AE. The size of this line segment AE. Okay, we want to find out the size of this line segment AE. So first of all, we will join points B and D by straight line. Actually, triangle EBD, this triangle is a right triangle. Okay, so I write it down. Triangle EBD is a right triangle. So we can implement the Pythagoras theorem on this right triangle, triangle EBD. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, dB square equals to EB square plus DE square. Again, in the right triangle, triangle EBD, according to the Pythagoras theorem, dB square equals to EB square plus DE square, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So dB square equals to EB square. EB equals to 2, so EB square is 2 square, 2 square is 4, plus DE square. DE equals to 8, and 8 square is 64. Okay, so we got that dB square equals to 4 plus 64, that is actually 68. dB square equals to 68. We will take a root out of equation number 1 and we will get the dB equals to the root of 68. So we can write here that dB equals to the root of 68. As you already know, all the angles inside the square are right angles. Therefore, angle DCB equals to 90 degrees. It is a right angle. And I will present to you a new rule, rule number 1. According to rule number 1, the diagonals of a square cross the angles of the square into 45 degrees. Okay, I'll repeat again on rule number 1. According to rule number 1, the diagonals of a square cross the angles of the square into 45 degrees. So actually we have here diagonal DB. So according to rule number 1, the diagonal DB crosses those two angles into 45 degrees. So angle BDC will be equal to 45 degrees, because it divides the angle of 90 degrees to two equal parts. This is to say 90 degrees over 2 is 45 degrees, and this angle will be also equal to 45 degrees. And we know that triangle BDC, this triangle is a right triangle. Triangle BDC is a right triangle. Okay, triangle BDC is a right triangle, therefore if we define DC as y, then in the right triangle BDC, cosinus 45 degrees will be equal to y over dB. I will repeat again. In the right triangle DBC, cosinus 45 degrees equals to y over dB, but we know that dB equals to the root of 68, so we can write here that it equals to y over root of 68. So here we will multiply equation number 2 by the root of 68. We know that cosinus 45 degrees is root 3 over root 2 over 2. And we multiply the equation number 2 by the root of 68. So we got that y equals to root 2 over 2 times the root of 68 according to equation number 2. We know that 68 is 34 times 2, so I write it down that according to equation number 2, root 2 times 34 times 2 equals to over 2 equals to y. We substituted 68 by 34 times 2. Here we can split the root to 2 roots. The root of 34 times 2 is root of 34 times root 2. So we will get that according to equation number 2, root 2 over 2 times root 2 over root 34 equals to y. Root 2 over 2 is 2. So we have 2 over 2 times root 34 equals to y. 2 over 2 is 1, so we will get that y equals to the root of 34 units. So actually all the sides of a square are equal to each other, therefore all the sides of square ABCD will be equal to the root of 34 units. So I will write it down that side DC equals to the root of 34 units. So is also side BC of square ABC. D equals to the root of 34 units. Side AB also equals to the root of 34 units, and the side AB, side AD, this side also equals to the root of 34 units. Okay, so actually we also know that angle DAB is a right angle because all the angles inside a square are right angles, therefore it is 1 out of 4 angles of square ABCD, therefore it equals to 90 degrees. And we have also, I will present to you rule number 2. According to rule number 2, if line segment AB subtends two equal angles, then quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C, and D lie on that circle. I will read rule number 2 again. According to rule number 2, if a line segment AB subtends two equal angles, then the quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have quadrilateral, if you have line segment AB this is line segment AB, and we have two equal angles that subtend on this line segment AB. So we have, this is the first angle theta, so actually angle CAB equals to theta, and angle CAB subtend on line segment AB. And we have also the second angle, angle ADB. This angle also equals to theta, and angle ADB also subtend on the same line segment AB. So if this is the reality, then according to rule number 2, the quadrilateral ABCD, that is to say this quadrilateral ABCD is inscribed by this blue circle. Again, quadrilateral ABCD is inscribed by this blue circle, and the 4 points A, B, C, and D lie on this blue circle. Okay? Again, if we have line segment AB and we have two equal angles, like those two equal angles that subtend on the same line segment AB, then according to rule number 2, the quadrilateral ABCD is inscribed by this blue circle, and the 4 points A, B, C, and D lie on this blue circle. Okay, that is according to rule number 2. And we actually can implement rule number 2 in our drawing, because we have two equal angles that subtend on line segment DB. I will write it down. Angle DAB that equals to 90 degrees. This angle subtend on line segment DB. And repeat again. angle DAB that equals to 90 degrees, subtend on line segment DB, and angle DEB, this angle DEB, that is also a right angle, equals to 90 degrees, subtend on line segment DB. So you can see from the drawing, those two equal angles, those two angles are equal to 90 degrees, and they subtend on the same line segment DB. It is also the diagonal of square ABCD. Okay, so we have two equal angles that subtend on the same line segment DB. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by a circle, and the 4 points AEBD lie on that circle. So, according to rule number 2, the quadrilateral AEDB subtend on a circle, so because of the fact that we have two equal angles, they are both equal to 90 degrees, they subtend on the same segment line BD. Therefore, quadrilateral AEBD is inscribed by a circle. As you can see, quadrilateral AEBD is inscribed by this blue circle, and the 4 points AEBD lie on that circle, on this blue circle, according to rule number 2. That is actually the implementation of rule number 2 in our drawing. Okay, that is true according to rule number 2. And we have also rule number 3. We will draw here two diagonals, and it will be also related to rule number 3. So this drawing relates also both to rule number 2 and also to rule number 3. Okay, we have here two diagonals, diagonal AB and diagonal DE of quadrilateral AEBD. And according to rule number 3. According to rule number 3, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. I'll read rule number 3 again. Rule number 3 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this circle and inside this circle you have quadrilateral ABCD is inscribed by this circle, again quadrilateral ABCD is inscribed by this blue circle, you can see from the drawing this quadrilateral ABCD is inscribed by this blue circle, and we also know that side AB equals to A units in its size, side BC equals to B units in its size, side DC equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. And we also have two diagonals, diagonal AC we will define diagonal AC as X, that is to say AC equals to X units in its size, and we will define diagonal BD as Y, that is to say BD equals to Y units in its size. Then, according to rule number 3, the product of diagonals A, B, C, the product of quadrilateral A, B, C, D diagonals, the product of this quadrilateral ABCD, the product of the diagonals, it is actually x times y. And according to rule number 3, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The quadrilateral ABCD has two pairs of opposite sides. The first pair is side BC is the opposite side of side AD, and the product of those two opposite sides, it is actually B times D. And the second pair of opposite sides are AB is the opposite side of side DC, and the product of those two opposite sides, it is A times C. And according to rule number 3, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides is BD, the second product of its opposite sides is AC, and the sum of the products of its opposite sides, it is actually BD plus AC, or XY, the product of its diagonals, equals to the sum of the products of its opposite sides, that is to say it equals to BD plus AC. So XY equals to BD plus AC in quadrilateral that is inscribed by a circle. Okay, so we can actually implement rule number 3 in our drawing. This is actually our drawing. So because of the fact that we have two angles that subtend on the same segment line DB, we have here this angle ABD, this angle ABD, it is actually right angle. It subtends on line segment DB. It equals to 90 degrees. This angle is a right angle, it equals to 90 degrees. And we also have the second angle DEB. This angle is also a right angle, it equals to 90 degrees. So we have those two right angles that subtend on the same segment line BD. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by this blue circle, and the 4 points AEBD lie on this blue circle. So we have this drawing. This drawing is true according to rule number 2. According to rule number 2, the quadrilateral AEBD is inscribed by this blue circle, and the 4 points AEBD lie on in this blue circle. Why? Because we have two equal angles that subtend on the same segment line DB. Therefore, the quadrilateral AEBD is inscribed by this blue circle, and the 4 points AEBD lie on this blue circle. Okay, so this is actually the implementation of rule number 2 in our drawing. So now we will implement rule number 3 in our drawing. So we have quadrilateral AEBD that is inscribed by this blue circle. Therefore, according to rule number 3, the product of quadrilateral AEBD sides and the product of its diagonals, it is actually AB times DE, AB times DE, AB times DE, and this product equals to the sum of the products of its opposite sides. we have side DB is opposite to side AE. So the first product of its opposite sides, it is actually DB times AE. And the second product of its opposite sides, we know the side AD is opposite to side BE. And the product of those two opposite sides, it is AD times AB. AD times AB. AD times EB. Okay? So, according to rule number 3, first of all, this drawing is the implementation of rule number 2 in our drawing. Okay, then we implement rule number 3 in this drawing. According to rule number 3, we have, because of the fact that we have a quadrilateral AEBD that is inscribed by this blue circle, then the product of its diagonals, that is to say AE times DE, AB times DE, the product of quadrilateral AEBD diagonals is AB times DE equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, it is actually the first product of its opposite sides is AE times DB, and the second product of its opposite sides is AD times EB, and the sum of the product of its opposite sides is DB times A plus AD times EB. Okay, this is the implementation, this formula is the implementation of rule number 3 in our drawing. Okay, so the only thing that is left to do is to put the data inside this equation number 3. We know that AB equals to square root of 34. Okay. And DE equals to 2 units. It is given us in the question. All equals to DB. DB equals to the square root of 68 times AE. AE is the missing variable that we are looking for, so we leave it as it is, plus AD. AD equals to square root of 34 times EB. Times EB. EB equals to 2. EB equals to 2. So actually here it is DE. Here we have DE and DE. DE equals to 8. So here I mistakenly wrote 2, but DE equals to 8. Okay, DE equals to 8 units. AB equals to square root of 34. DB equals to square root of 68. AE is the missing variable. AD equals to square root of 34, and EB equals to 2 units according to what is given us in the question. So here we will substitute square root of 68 by square root of 34 times square root of 2, and we will get that square root of 34 times 8 equals to square root of 34 times square root of 2 times AE plus square root of 34 times 2. So here we will divide equation number 3 by square root of 34. So here square root of 34 will get cancelled. And what is left after we cancel square root of 34? What is left is it is actually 8 equals to root 2 times AE. This is the missing variable, plus 2. So here we will substitute 2 from equation number 3. 8 minus 2 is 6. So 6 equals to square root of 2 times AE. Here we will divide equation number 3 by 6. We will divide equation number 3 by square root of 2. And we will get that AE equals to 6 over square root of 2. Okay, but we know that 6 equals to 3 times 2. So I'll write it down. So AE will be equal to, so instead of 6 we'll write 3 times 2, or 2 times 3 over root 2. So we got that AE equals to 2 times 3 over root 2. We will multiply this equality by root 2, and then we will divide it by root 2, and we will get that, so we will change nothing. So AE equals to 2 times 3 over root 2. We will multiply it by root 2, and then we will divide it by root 2, and we will get that it equals to 2 times 3 times root 2 over 2. 2 over 2 is 1, so 2 will get cancelled. And we got that AE equals to 3 times root 2 units. AE equals to 3 times root 2 units, or in terms of numbers, AE equals to root 2 times 3 AE equals to 4.243 units. So we have two different ways to present the same answer. The answer to the question is that line segment AE, this line segment AE equals to either 3 times root 2 units, or in terms of numbers, line segment AE equals to 4.243 units. Okay, I will repeat again. Line segment AE equals to 3 times root 2 units, or in terms of numbers, line segment AE equals to 4.243 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the value of line segment AE, and we know that ABCD is a square, and we also know that EB equals to 2 units and DE equals to 8 units, and we want to find out the size of line segment AE. Okay. So first of all, we connected together points D and B by a straight line. So actually DB is the diagonal of square ABCD, and the triangle EBD, this triangle is a right triangle. Therefore, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle EBD. That is to say, BD square equals DB square equals to EB square plus DE square. And we know that EB equals to 2 units. Therefore, EB square is 2 square is 4. And DE equals to 8 units. Therefore, DE square is 8 square. 8 square is 64. And DB square equals to 4 plus 64 is 68. DB square equals to 68. We took a root of the question number 1 and we got that dB equals to the root of 68. Okay, dB equals to the root of 68. And then I presented to you rule number 1. According to rule number 1, the diagonals of a square cross the angles of the square into 45 degrees. That is to say, the diagonals of a square divides the angles of the square into 2 equal parts. And we know that all the angles inside the square are right angles, and the diagonal divides it to 2 equal parts. That is to say, divides it to 45 degrees. Okay, so angle this, we have diagonal DB inside square ABCD. So according to rule number 1, diagonal DB divides the angles of this square into 45 degrees. So this angle equals to 45 degrees, angle BDC equals to 45 degrees, and this angle DBC also will be equal to 45 degrees. Okay, and we also know that triangle BDC, this triangle is a right triangle because this angle equals to 90 degrees. All the angles inside a square are right angles, so it is 1 out of 4 angles of square ABCD, therefore it is a right angle. Therefore triangle DBC is a right triangle. Therefore, if we focus on triangle DBC, cosinus 45 degrees will be equal to DC over DB, and we define DC as y, so cosinus 45 degrees will be equal to y over dB. But we have already found out that dB equals to the root of 68, so we can substitute dB by the square root of 68. So we got that cosinus 45 degrees equals to y over square root of 68. And we know that cosinus 45 degrees equals to root 2 over 2. So we multiplied equation number 2 by the root of 68. And we got that root 2 over 2 times root of 68 equals to y. And then we know that 68 is 34 times 2. So we substituted 68 by 34 times 2. And we got that this expression equals to y. Then we split this root to 2 roots. That is to say, the root of 34 times 2 equals to the root of 2 times root 34. And we know that root 2 times root 2 is 2. So we got here 2 over 2 times the root of 34 equals to y. 2 over 2 is 1. So we got that y equals to square root of 34. Y is actually DC, so one side of square ABCD equals to square root of 34, and we know that all the sides of a square are equal to each other. Therefore, all the other sides of square ABCD equals to square root of 34 units. So we found out actually that the sides of square ABCD, they are all equals to square root of 34, and we also know all the other variables. We know that the size of dB equals to square root of 68. We know that DE equals to 8 units. We know that EB equals to 2 units, and the only missing variable is AE. Line segment AE is the only missing variable. And I also presented to you rule number 2. According to rule number 2, if a line segment AB subtends two equal angles, then the quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. I will read again. If a line segment AB subtends two equal angles, then the quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have line segment AB, this line segment AB in the red color, and this line segment AB subtend two equal angles. So in other words, two equal angles rest on line segment AB. This angle theta, angle ACB equals to theta, and it rests on line segment AB, and this angle ADB also equals to theta, and it rests on the same line segment AB. So we have two equal angles that subtend on the same line segment AB. Therefore, according to rule number 2, the quadrilateral ABCD is inscribed by this blue circle, and the 4 points A, B, C, and D lie on that blue circle. Okay, that is the implementation of rule number 2 in our drawing. So we actually can draw a circle around quadrilateral ABCD, and the 4 points A, B, C, and D will lie on that circle. This is according to rule number 2. Okay? And we can implement rule number 2 in our drawing because we have two equal angles. Those two angles are equal to 90 degrees, and they are both subtend on the same line segment BD. Okay, angle DAB that equals to 90 degrees subtend on line segment DB, and angle DEB that also equals to 90 degrees subtend on the same line segment DB. Okay, we have two equal angles that subtend on the same line segment DB. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. Okay, so according to rule number 2, because of the fact that we have two equal angles, both those two angles are equal to 90 degrees, and both lie on the same line segment DB. Or the rest, those two equal angles subtend on the same line segment DB, or the rest on line segment DB. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay, this is the implementation of rule number 2 in our drawing. Okay, and I also presented to you rule number 3, according to rule number 3, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this quadrilateral ABCD in the red color, and this quadrilateral ABCD is inscribed by this blue circle. Okay? So in this case, according to rule number 3, then the product of its diagonals, that is to say x times y, equals to the sum of the squares, equals to the sum of the products of its opposite sides. So the products of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides is b times d, and the second product of its opposite sides is a times c, and the sum of the products of its opposite sides is bd plus ac. Or in other words, xy, that is the product of its diagonals, equals to the sum of the products of its opposite sides, equals to bd plus ac. This is rule number 3, and we implemented rule number 3 in our drawing. First of all, we know that according to rule number 2, because of the fact that those two angles subtend on the same segment line, then the quadrilateral AEBD is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. So this is true according to rule number 2. So therefore we have here quadrilateral AEBD that is inscribed by this blue circle. Therefore we can implement rule number 3 in our drawing. And according to rule number 3, because we have quadrilateral ABD that is inscribed by this blue circle, the product of its diagonals, the product of quadrilateral AEBD diagonals is AB times DB, is AB times DE. The product of quadrilateral AEBD diagonals is AB times DE. And this product, according to rule number 3, equals to the sum of the products of its opposite sides. And a quadrilateral AEBD has two pairs of opposite sides. AE is opposite to BD, and the product of them is AE times DB. This is the first product, AE times DB. And the second product of its opposite sides, AD is opposite to EB. And the product of those two opposite sides is AD times EB. AD times EB. So according to rule number 3, the product of its diagonals, that is actually AB times DE, equals to the sum of the products of its opposite sides. But what is the sum of the products of its opposite sides? The sum of the products of its opposite sides is DB times AE, and AD plus times EB. DB times AE is the first product, AD times EB is the second product of its opposite sides, and the sum of the products of its opposite sides is DB times AE plus AD plus AB. And this sum of the products of its opposite sides, according to rule number 3, equals to the products of its diagonals, that is actually AB times DE. So equation number 3 is the implementation of rule number 3 in our drawing. Okay? The product of quadrilateral AEBD diagonals, that is AB times DE, and this product equals to the sum of the products of its opposite sides, equals to AE times DB, that is the first product, plus the second product, AD plus EB, the second product of its opposite sides. the sum of the products of his opposite sides is this expression, and it equals to the products of his diagonals, that is AB times DE. Okay? I will repeat again. Question number 3 is the implementation of rule number 3 in our drawing. In this drawing, the product of quadrangular AEBD diagonals is AB times DE, and this product equals to the sum of the products of its opposite sides, equals to DB times AE plus AD times AB. Okay? This is the implementation of rule number 3 in our drawing. Question number 3. But we know that AB equals to square root of 34, and DE equals to 8 units. DB equals to square root of 68, and AE is the missing variable. And we know that AD equals to square root of 34 and EB equals to 2. It is given us the question. Okay? So the only missing variable here is AE. So here we substituted 68 by root of 68 equals to root of 34 times root 2. Okay, because 68 is 34 times 2. So we split this root to 2 roots, and we got that square root of 68 equals to square root of 34 times square root of 2. Okay, so we divided the question number 3. This equation by square root of 34. So square root of 34 get cancelled, and we got that 8 equals to square root of 2 times AE plus 2. Here we subtracted from equation number 3 2. 8 minus 2 is 6. So we got that 6 equals to root 2 times AE. Then we divided equation number 3 by square root of 2, and we got that AE equals to 6 over square root of 2. Okay, but we know that 6 equals to 3 times 2, so we substituted 6 by 3 times 2, or 2 times 3, so AE equals to 2 times 3 over root 2. Here we multiplied this expression by root 2, and then we divided it by root 2, so we changed nothing. So here we have 2 times 3 times root 2, and root 2 times root 2 is 2, and 2 over 2 is 1. So we got that AE equals either to 3 times root 2 units, this line segment AE equals to either 3 times root 2 units, or in terms of numbers, line segment AE equals to 3.243 units. I repeat again, AE equals to either 3 times, this line segment AE equals to either 3 times root 2 units, or in terms of numbers, line segment AE equals to 4.243 units. Okay, AE equals to 4.243 units, or it will be equal also to 3 times root 2 units. It is another way to represent the same result. Okay, thank you very much.